Good morning, students. Today our topic is refraction. Refraction is nothing but when light travels from one optical medium to another medium, the path of light should be deviated, which means the path of light is bend its original path. This is called as refraction. See, this is medium 1, this is medium 2. In ray optics, the medium is classified as two types. One is a rarer medium, another one is denser medium. What is rarer medium? Rarer medium is nothing but, so density is very low. That is rarer medium. If density is maximum, that is called as denser medium. Or velocity of light is minimum, is called as denser medium. See the medium 1, this is medium 2. The light should travel from one medium to another medium, which in example rarer to denser or denser to rarer. Light travel from one optical medium to another medium. The path of the light is deviated. And this is incident ray, this is refracted ray. The incident ray, this is the refracted ray should be bent from its original path. This is called as refraction. Here, this is angle of incidence. This is angle of refraction. This is deviation angle. Deviation angle. This is a refraction. Refraction, it is mainly measured sine of angle of incidence to the sine of angle of refraction. To measure the incidence angle and to measure the refracted angle based on Snell's law. In Snell's law, law of refraction is called as Snell's law. Snell's law in based first reflection one, law of reflection. Angle of incidence is equal to angle of reflection. Second one, the incident ray, reflected ray and normal to the surface all lie in same plane, which means coplanar. This is law of reflection. Another one, Snell's law, laws of refraction. Refraction, laws of refraction. Here, incident ray and refracted ray, this is normal to the surface, all lie in same plane. Another one, sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is equal to constant. Which means I sine of which means I is the angle of incidence, R is the angle of refraction. Sine of angle of incidence, the ratio of sine of angle of incidence, sine I divided by sine R is equal to constant. The constant is nothing but this is a refractive index. So sine I divided by sine R is equal to refractive index. The refractive index is a mainly second medium with respect to first medium. The sine I divided by sine R is equal to constant. The constant is nothing but this is the refractive index of medium. The refractive index of medium, there are two medium. One is medium 1, this is medium 1, medium 2. The refractive index of first medium is N1. The refractive index of second medium is N2. Though, according to Snell's law, the ratio of sine of angle of incidence to sine of angle of refraction is equal to constant. The constant is nothing but this is a refractive index, second medium with respect to first medium. So, sine I divided by sine R is equal to N2 divided by N1. This is law of refraction, Snell's law of refraction. See, N1 sine I equal to N2 sine R. This is laws of refraction. This is the main concept. This is an important formula one. Ratio of sine of angle of incidence to the sine of angle of refraction is equal to constant. The constant is nothing but this is a refractive index. The refractive index with respect to second medium with respect to first medium. So sin I divided by sin R is equal to n2 divided by n1, or n1 sin I is equal to n2 sin R. And next one, rarer and denser. What is a rarer? Rarer medium. The velocity of light is maximum in rarer medium. Velocity of light is low in denser medium. The medium is mainly classified as depends on density. The density is nothing but mass by volume. So density, if density low, the medium is rarer. If density is maximum, the medium is denser. The velocity of light is maximum. That is rarer medium. Velocity of light is low. That is denser medium. See, in rarer medium, velocity of light, I want to take VR. In denser medium, velocity of light in medium. So in rarer medium, light velocity is maximum. In denser medium, light velocity is minimum. The dense is low dense, denser medium, so high density. What happens when light travels from rarer medium to denser medium? When light travels from rarer to denser, what happens? There is a light incident in medium of 1 m1. This is incident ray. On incident point after the surface, this is called as normal. The angle between normal and incident ray is angle of incidence. When light travels from one medium to another medium, in first medium is rarer medium, second one is denser. In velocity of light in first medium is v1, the velocity of light in second medium is v2. The frequency of light in first medium is f. Frequency of light in second medium is also f. Because of the frequency of light is not changed. It remains constant from rarer to denser. But the velocity and wavelength must be changed. The wavelength of first medium is lambda 1. The wavelength of second medium is lambda 2. That's why I want to take this is rarer medium, this is denser medium. What happens when light travels from rarer to denser? Light travels from rarer medium to denser medium. The refracted ray must be bent towards normal. This is original path, it's a real path. The light must be bent towards normal. The light must be bent towards normal when light travels from rarer to denser medium. This is angle of refraction. This angle of refraction. This is deviation angle. Deviation angle. What happens? Light travels from rarer to denser. When light travels from rarer medium to denser medium, after refraction, bend towards normal. Bend towards normal. This is n, this is n dash. The refracted ray must be bent towards normal. Velocity of light. What happens velocity of light? This is in rarer medium, velocity of light is maximum. In denser medium, the velocity decreases. The frequency of light must be same. The frequency of light does not change, it remains constant. Or one color light, any one of color light incident one medium to another medium, the color does not change. The color does not change, but the wavelength and the velocity change. So, because of the color depends on frequency only. Because the frequency remains constant from one medium to another medium, from denser rarer to denser medium. That's why the color does not change, but the wavelength and the velocity change. So velocity, what happens? Velocity in denser medium decreases. Frequency remains constant. Wavelength decreases. Wavelength decreases. So V2 is the velocity of light in denser medium. What happens? In first medium V1, this is second medium V2. frequency first medium, second medium frequency, wavelength first medium lambda 1, wavelength second medium lambda 2, refractive index of first medium n1, refractive index of second medium is n2. What happened? Velocity in rarer medium maximum, compare than second medium. Frequency remains same. Wavelength decreases. Wavelength decreases. In second medium, wavelength decreases. So V1 greater than V2, frequency remains same. What happened? Refractive index. This is N1, this is N2. In denser medium, refractive index is maximum. Refractive index maximum. Refractive index is nothing but is a constant to measure and identify the medium. For example, light in glass, refractive index is 1.5. In water, 1.33. 1.33 refractive index. The refractive index is inversely proportional to wavelength and inversely proportional to temperature, but directly proportional to density. Directly proportional to density. Inversely proportional to temperature, inversely proportional to wavelength. So refractive index is a very important one. It's a constant. There, according to Snell's law, ratio of sine of angle of incidence to the sine of angle of refraction is equal to constant. The constant is nothing but the refractive index. Refractive index second medium with respect to first medium. Second medium with respect to first medium. This is when light travel from rarer medium to denser medium. What happened when light travel from denser to rarer? Denser to rarer. Consider this is denser medium, this is rarer medium. This is angle of incidence, I. Angle of incidence, I. Listen to me, it's very important. When light travel from denser to rarer, when light travel from rarer to denser, after refraction, bend towards normal. When light travel from denser to rarer, after refraction, away from normal. This is as it is. This is original part. This is away from normal. This is angle of refraction. Angle of refraction. When light travel from denser medium to rarer medium, after refraction, away from normal. It is a very important content. Rarer to denser, after refraction, bend towards normal. Denser to rarer, away from normal. Away from normal. See what happened? Velocity. Denser medium velocity decreases. Rarer medium velocity increases. So here minimum velocity, here maximum velocity. This is wavelength minimum. Here wavelength maximum. Refractive index of this medium is N1. This medium is N2. This is denser medium. So N1 greater than N2. N1 greater than N2. This is the first medium is a denser medium. Second medium is rarer medium. In denser medium, velocity of light is minimum. So velocity minimum, here velocity maximum. After refraction, denser to rarer, velocity maximum, here velocity minimum. Here wavelength minimum, here wavelength maximum. So refractive index, first medium is denser, so N1 greater than second medium N2. It is a very important one. What happened? Snell's law. What says Snell's law? Sin I divided by sin R is equal to second medium with respect to first medium. N2 divided by N1 is equal to C divided by V. What is C? Velocity of light in vacuum or rarer medium. This is V is the velocity of light in given medium. So sin I divided by sin R is equal to C by V. C by V is equal to, C is equal to nu lambda 1 divided by V is equal to nu lambda 2. What is lambda 1? Wavelength in rarer medium. This is wavelength in given medium or denser medium. So lambda 1 is nothing but this is first medium, rarer medium. So if frequency is same, so that's why frequency cancel. So sin I divided by sin R is equal to refractive index, second medium with respect to first medium, or sin I divided by sin R is equal to C by V, or sin I divided by sin R is equal to lambda 1 divided by lambda. This is the equations of light travel from rarer medium to denser medium or denser medium to rarer medium. Just is an important point. Rarer to denser after refractor bend towards normal. Denser to rarer after refraction away from normal. This is the main concept. So formula sin I by sin R is equal to n2 divided by n1, second medium with respect to first medium, refractive index of second medium with respect to first medium, which is equal to C by V, which is equal to lambda 1 divided by lambda 2. Next, angle of deviation. What is the angle of deviation? The angle between incident ray and refracted ray is called as angle of deviation. Listen to me. This is rarer medium, this is denser medium. This is incident ray, angle of incidence. Angle of incidence. Rarer to denser after refraction bend towards normal. This is incident ray. Bend towards normal. Actually, the path of the light should be bent towards normal. This is called as a refraction. This is angle of refraction. Angle of refraction. Normal. So angle between normal and incident rays, angle of incidence. This is angle of refraction. This is the incident ray. This is angle between incident ray and refracted rays, angle of deviation. Angle of deviation. What is the formula of angle of deviation? See, just imagine, if consider when light just travel in straight line, this overall is I. This also I, this also I. So R plus D equal to I. R plus D is equal to I. So D is equal to I minus R. So the D value is I minus R. This is the angle of deviation when light travel from rarer to denser. Rarer to denser. It's a very important one. When light travel from rarer to denser, deviation angle is equal to I minus R. What happened? When light travel from denser to rarer. This is medium, denser, this is rarer. Because of the light travel from away from normal. That's why this is denser medium, this is rarer medium. This is angle of incidence. What is this? Angle of refraction. Angle of refraction. This is angle of deviation. This is angle of deviation. What is this? I. Angle of incidence. So I plus D is equal to R. I plus D is equal to R. So D is equal to R minus I. R minus I. When angle of deviation is D is equal to I minus R, light travel from rarer to denser. The angle of deviation is R minus I when light travel from denser to rarer. This is a very important one. So D is equal to I minus R when light travel from rarer to denser. D is equal to R minus I when light travel from denser to rarer. Next is the principle of reversibility. It's nothing but follow the light, the exactly same path. It is travel in reverse, which means the path should be reversed. The travel in the direction of light is reversed. For example, is a reflecting surface, not a refracting surface. Reflecting surface. This is this is incident ray. This is normal I. This is reflection. This is angle of reflection. This is reflected ray. According to Snell's law, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. That is angle of reversibility. See, this is incident ray. Here I value is equal to R. Angle of incidence is equal to angle of reflection. When light is reversed in same path. Now this is angle of incidence. Reflected in same path. This is angle of reflection. According to Snell's law, I is equal to R. So the angle of reversibility, I mean the properties, principle of reversibility is based on the Snell's law. So I is equal to R. So the incident ray reflected and same one incident reflected because of I is equal to R. This is reflection. And next one, the incident ray, normal angle of incidence. This is refracted ray. When we are using on plane mirror, the light must be reversed in same path. So R value. So I, this is angle of incidence, this is angle of refraction. According to Snell's law, sin I divided by sin R is equal to second medium with respect to first medium. Second medium with respect to first medium. In reverse process, sin R divided by sin I is equal to first medium with respect to second medium. Same phenomena. So here, sin I divided by sin R is equal to N2 divided by N1. Which means second medium with respect to first medium. Sin R divided by sin I is equal to N1 divided by N2, which is equal to first medium with respect to second medium. So both are equal. That's why the principle of reversibility is possible. So sin I divided by sin R is equal to second medium with respect to first medium. Sin R divided by sin I is equal to first medium with respect to second medium. If this is angle of incidence, means this is angle of refraction when reverse process. See, second medium with respect to first medium, which is equal to N2 divided by N1. First medium with respect to second medium is equal to N1 divided by N2. What happened? Second medium N2 into N1 into N1 divided by N2 is equal to 1. Is equal to 1. So here, second medium with respect to first medium, which is equal to 1 divided by N1 divided by N2. N1 divided by N2. Second medium with respect to first medium, which is equal to 1 divided by first medium with respect to second medium. So this is chain rule or refractive index, principle of reversibility. Sin I by sin R is equal to N2 divided by N1, or sin R divided by sin I is equal to N1 by N2. So finally, N2 divided by N1 is equal to 1 divided by N1 divided by N2. Second medium with respect to first medium is equal to 1 divided by first medium with respect to second medium. This is a principle of reversibility. Relative refractive index. Relative refractive index, which means when light travel from one medium to another medium. This is rarer, this is denser. This is normal angle of incidence. This is also normal. What happens after refraction? Bend towards normal. Bend towards normal. This is a medium 1. This is a medium 2. Refractive index of first medium N1, second medium N2. After denser to rarer. This is normal angle of incidence. Denser to another one. This is rarer medium. What happened? Away from normal. Away from normal. This is a refractive index is N3. This is a relative refractive index. One is in reverse rule and chain rule. First one reverse is second medium with respect to first medium. So N2 respect to N1, which means second medium with respect to first medium, which is equal to N2 divided by N1. Or first medium with respect to second medium, which is equal to N1 divided by N2. N1 divided by N2. Here, second medium with respect to first medium into first medium with respect to second medium, which is equal to 1. So that's why second medium with respect to first medium, which is equal to 1 divided by first medium with respect to second medium. This is inverse rule. Refractive index of N32 is equal to N31 into N12. Third medium with respect to second medium, which is equal to third medium with respect to first medium and first medium with respect to second medium. So which is equal to N31 means N3 divided by N1 into this is N1 divided by N2. So N1 cancels, so N3 divided by N2. This is chain rule, called as chain rule. So N32 is equal to N31 into N12. Third medium with respect to second medium, which is equal to third medium with respect to first medium into first medium with respect to second medium. This is chain rule. So N32 is equal to N3 divided by N2. The refractive index, relative refractive index. So light travel through a transparent oil enters into glass of refractive index is 1.5. If refractive index of glass with respect to oil is 1.5. The refractive index of glass is 1.5. So I want to take the refractive index of glass mu g is equal to 1.5. Here mu is the refractive index. So mu g is equal to 1.5. Refractive index of glass. Refractive index of glass with respect to oil. Glass with respect to oil. Mu g. G is a glass, O is oil. Refractive index of glass with respect to oil, which is equal to mu g divided by mu oil O. Refractive index of glass and oil. So if refractive index of glass with respect to oil is 1.5, so which is equal to 1.25. 1.25. What is the refractive index of oil? So refractive index of oil, mu O is equal to 1. Yes, you know well. The direct formula. So refractive index of glass with respect to oil is equal to mu g divided by mu O. You know well mu g divided by mu O is equal to 1.25. And individually refractive index of glass mu g is equal to 1.5. So I want to calculate refractive index of mu O. So mu g divided by mu O is equal to 1.25. Mu g value is 1.5. So 1.5 divided by refractive index of oil is equal to 1.25. So I want to calculate the refractive index of oil is equal to 1.5 divided by 1.25, which is equal to 1.2. Refractive index of glass and water with respect to air. It is very important. With respect to air medium means refractive index of air is equal to 1. So that's why I want to take in refractive index of glass. Mu g divided by mu r. Mu r value equal to 1. With respect to r means which is equal to 3 by 2. Here mu r value is equal to 1. That's why I want to take directly mu g is equal to 3 by 2. With respect to r medium, refractive index of r medium is equal to 1. That's why I want to take directly refractive index of glass, which is equal to 3 by 2. Refractive index of glass and water with respect to air. First one, glass is 3 by 2 and water mu w is equal to 4 by 3. 4 by 3. What is the refractive index of glass with respect to water? Refractive index of glass with respect to water. First one, refractive index of glass with respect to water, which means refractive index of glass with respect to water means which is equal to mu g divided by mu water. Second medium glass, first medium water is very important. Glass with respect to water, which is equal to mu g divided by mu w. Mu w is a water medium, refractive index of water, which is equal to what is mu g value? Refractive index of glass with respect to air, mu g divided by mu r. Refractive index of water with respect to air, this is mu r, is equal to 4 by 3. So glass with respect to air is equal to 3 by 2. Water with respect to air is equal to 4 by 3. Glass with respect to water, which is equal to mu g divided by mu r whole divided by mu water divided by mu r. The refractive index of air is equal to 1. That's why I have to take mu g divided by mu water. What is mu g values? 3 by 2 divided by mu water 4 by 3, which is equal to 3 divided by 2 into 3 divided by 4, which is equal to 9 by 8. Refractive index of glass with respect to water is equal to 9 by 8. But reverse refractive index of water with respect to glass is equal to 8 by 9. So very important. Just want to read on exactly question. What is the refractive index of glass with respect to water is 9 by 8. refractive index of water with respect to glass is equal to 8/9.